So in this problem we have a canvas wind shelter for the beach. It has a back, 2 square sides, boom, there and there, and a top here, okay. If 24 square feet of canvas is to be used, well then that means this is a teeny tiny tent. But anyways, find the dimensions of the shelter for which the space inside is maximized. Okay. So the problem is to find the volume of the shelter. Now in this problem it's broken down for you step by step. Okay, that's partly to make sure you're following the right process for doing these problems. Okay, V is going to be the volume. Okay, next assign other letter quantities that may vary. So they're doing this for us because it's the only way for them to break it down step by step as if they assign the letters. So they're going to let S be the length of one of the square sides. Let's see, it says it has a back, 2 square sides, and a top. So that must be this side. So this must be S, and since it's a square, that must be S, that must be S, that must be S. Okay, and Z is the width, yeah, so this length all the way across there, or I'll put it up here, is Z. Okay, so write an equation for the volume using the variables S and Z. Notice that the ends of the figure are squares. So volume is still, it's a box. I mean, although it's missing the bottom and this front, it's still a box. So it's still, the volume is still length times width times height. So S times Z, S or S squared times Z, and we're just going to have to go enter this in here. Okay, to get the next part. So 24 square feet of canvas are to be used. Which of the following formulas represent the total surface area? Okay, so we have a side, 2 square sides, both of S, both of squares with size S. So the area of this side is S squared, and the area of that side is S squared. So when we add those areas together, we get S squared plus S squared, or 2S squared. Those are the areas of the 2 square sides, plus the area of the back is Z times S, and the area of the top here, well, that is a square, so that length right there is also S, so it's also ZS, so 2ZS, so 2S squared plus 2ZS, let's see, that one I think right there. Here's the constraint equation for the surface area to simplify the objective function in such a way that it becomes a function of only one variable. Begin by solving the constraint equation in terms of Z. Okay, so let's do that over here. And the total area in this case is 24. So we're going to solve this for Z. This doesn't have any Z's, so I'm going to start by subtracting 2S squared from both sides, and we'll divide both sides by 2S. We can take a 2 out of everything, although we cannot take an S out of everything, so that would become 12, and then those 2's go away. So we'll have 12 minus S squared all over S. I suppose you could also write that, and eventually we may do this, 12 minus S squared all times S to the minus 1, which you could then distribute out, so you'd have 12 S to the minus 1 minus S to the, adding these exponents, 2 plus negative 1 is 1. Actually kind of like that version right there. So, partly because we're going to differentiate it. Let's see if it'll take that. So Z is 12S to the minus 1 minus S. 12S to the, minus 1 minus S. Oh, nice. Okay. Then take the value of Z and use it to find the volume in terms of one variable. So we want to find V in terms of S, it says. Okay, so V, I'll plug it in up here. Oops. And there. V is S squared times Z. S squared times this. Oops, S squared times 12S to the minus 1 minus S is Z. Simplifying, we'll distribute the S squared. 2 minus 1 is 1, so I get 12S minus S, that's a 12S, for read, minus S to the 2 cubed, looks like 125. Be careful on that. 12S minus S cubed, it looks like. S actually want to usually write my variables in cursive. I just didn't on this one because everybody thinks my S looks weird. Okay, what is the next step? So we've found volume all in terms of one variable. So the next step is to find critical values with the objective function by differentiating V. So then what is that derivative? Okay, I can do this one by looking at this right here. So the derivative of 12s is 12 minus 3s squared. Okay, then we find the critical points by finding where it equals 0. So 12 minus 3s squared. So V prime is 12 minus 3s squared. Set that equal to 0 and solve that for critical values. So where does 12 equals 3? Switch to cursive. So s squared is 4. So s is plus or minus 2. Of course, negative values don't make sense here, so we're just going to go with positive 2 for the critical value s. What is the next step? Find the value of z using the constraint equation. We could do that. Test whether the critical value is a min or max. Using V double prime, to be honest, it doesn't matter which order you do that in, so I don't like that they've included both those options. That's okay. Use the value of S to find the volume, or test whether the critical value is a maximum or minimum using V prime. I'm going to go with, let's just go ahead and test to see whether it is in fact a min or a max. Let's see if it likes that option. Yeah. Okay, so we would need the second derivative. Oh, there it is. Asking for the second derivative. So, well, the first derivative is right here. The derivative of 12 is 0. So the derivative of negative 3s squared is negative 6s. So the derivative test using the critical value of s. So I think that's where they want us to plug in 2. We would get negative 12. I think that's what that's looking for. Yeah. It shouldn't say V double prime of S there. It should actually say V double prime of C or something. But it says to use your critical value for S. So, All right, then we find the value of Z using the constraint. That's this right here. So we're going to plug in for Z is when S is 2, 12 times 2 to the minus 1 minus 2. This means 12 over 2 to the first. So 6 minus 2 is 4. And that was it. Let me know if you still have any questions on that one.